Good day, Professor Teodoro Castillo. In this video, I explain my conclusion about the laboratory number 8. Uh, the, the topic was the ATC system and the VHF communication system. So, to this activity, the ATC system, um, in the schematic wiring, show the all components to conform. In this case is the panel of control, the ATC, and in this system is stays the TICAS, and then the transponder, um, the ATC, the switch codes, and two switch is interfaces with the antenna, the top antenna and the bottom antenna. This communication system is interfaced with all components. In this case, it stay the ADIRU, the multimodal receiver, and the flight management computer, the system of the ACARS, or all interfaces. So in this system, it's very important to know the three modes: the mode A, the mode C, and the mode S. And the mode A is the identification. So in this case, if you turn on the system, uh, the information in this case in the module show the lights in the code, binary codes. Then in the mode C, in the altitude, this show the light indication in the gray code. So when you have any problems in this system, uh, according of the troubleshooting, is first is isolation the fault. When you isolation the fault, for example, if you if you check if the transponder is the fail, and I isolation the all systems. And for example, in this case, I have um, any ideas to solve this component. For example, uh, I can check the bytes of this transponder, and with this button you put this button to test. In this case, if you if you see if you look the the lights in the color green, is the system in okay. So, and the other activity is the VHF communication. This is the schematical wiring about the plane, the Boeing 737. Well, in this case, show all components in the transceiver, then the control panel, the antennas, and the electronic unit, the equipment. So in this system, the VHF communication is important. Two types, in the sensibility and the selectivity. Um, and also it's important to check the power of transmission of the reception in this case. So when you have any problems about this in the with sensibility, it's necessary to apply the relation of wave stationary. This relation is important because the forward the power uh, into the power reflect. This value is shown with the bathymeter. When you have what bathymeter, um, you can check um, with a formula uh, the the information of the sensibility. Well, according the manual, with the relation in this on stationary is in number one or two, this component is okay. If you have for example the the information in number three or four, is this component is not okay. So then all fails to check is in the power of transmission. Is necessary to know the width for for 100 feet of the the transmission is if uh, I lose transmission or in 2 dBm. And in this manual, in this wiring, show the information. In this case, the supply is the 28 voltage in the bus standby. So when you have a micro, then the PTT pulls to torque. When you push to torque, in this case, you you transmit the the waves. In this case, the voice um, is carry with the waves carrier. Um, so when you push the PTT, the information arrive the information arrive for these lines. Then the information is processed in the control, and then the information check for this component. And this in this moment, this is interfaced and check in the modulator and direction coupler, and then send the voice and information for the antenna to receive another system, for example the ground station, or maybe another plane. So to this to do this to solve this problem about the VH communication is very important, using the troubleshooting. In this manual, show the step by steps to to isolation another fails. So it's all for my video. Thank you, Professor.